Okay, welcome to the Vision Brick. In this video, I will show you how to train faster RCNN object detection models. I have an article about this. You can watch the video or follow this article. Everything is same. So let me show you quickly what are we going to do. First, we will prepare our dataset. After that, we will set up our training environment. Then you can see I'm using PyTorch. After that, we will create custom PyTorch dataset class. After that, we will create two sets. One is train set, other is validation set. These two datasets will be used while training. Yeah, this step is not that important, but it's always good practice to see some random examples from your dataset. You see. Then we will load a pre-trained faster RCNN model. I will use ResNet 50 as backbone. You can use other models. The process is same. Then we will train our model. You can see the training process, yeah, like loss values and other things. Then we will load our trained model and make some detections. We will test our model on test images. Okay, we can start. First step is preparing dataset. You can create a dataset from scratch, like collecting images from internet or with your camera, then annotate those images with label image or like RoboFlow. But I will use this dataset. I found this from internet, like not internet, from RoboFlow. I choose it randomly. Let me show you some examples. Yeah, you see there's four classes. One is ball, other goalkeeper, player, and referee class. Let me show you a few more examples. You see referee, player, blah blah. So this is a small dataset, but this is not a problem. Even if you had like 10,000 images, all the process will be the same. So you can download dataset from here. Click dataset section, then download dataset. Download as zip. You can choose different formats from here. There's like Pascal, Coco, YOLO, but I will choose Coco. Download as zip, like this. Okay, after that, I already downloaded and unzip it to my main folder, my base folder. You see there's two more subfolders under this dataset folder, train and validation. Inside these folders there are images. You see these are training images and one JSON file, and this contains information about training set. You see, for example, let me show you image name here, like width and height. And if we go like this, you see image ID, bounding box coordinates, for example here, bbox. You see, yeah, it's like this. Validation is same, no need to repeat myself. So we can close this. Okay, so training environment. I have a GPU supported PyTorch environment. I will use it, but if you don't have a GPU supported PyTorch environment, you can use servers like Kaggle or Google Colab. They offer free GPU. You just need to update your dataset to these servers and activate GPU. Then you can train your model. I recommend you to use Kaggle because Google Colab has some restrictions. You can directly go with Kaggle. And if you don't like Kaggle, you can always try to Google Colab as well. Okay, other step is import libraries and check if GPU is available. Let me show you. I created one Jupyter notebook. I will train my model inside this main file. So you see, output must be device type CUDA. This means that your GPU is available and PyTorch will use GPU while training. So it will be like 20 times faster than training with CPU. Okay. Custom PyTorch dataset class for Coco format. Okay. You see we have a class, you can name it to whatever you want. You can see the constructor. There's image direction, image IDs, transforms. This will like normalize and rescale image. Here lamp method returns the total number of images, and getItem method will return image and target. And this target contains information about annotation. You see bounding boxes, labels, image ID, and other things. You can read these comment lines. Everything is simple I think. Okay. And other step is create train and validation sets. Okay. You see this is train dataset and this is validation set. Like you can see the paths from here. It's same as our dataset. Football players detection train. Football players detection train. And the second one is path to this JSON file. We already looked at it. Let me close this. And it's same for validation. Here you can load your datasets with data loaders. By the way, you can change the batch size. Because of my GPU's memory, I set it to 2 and 1. But if you have like powerful GPUs, you can set this size to 4, 8, 16, even 32. So it will be faster. I mean, your training will be faster. Yeah, okay, it's done. Then let me look other step. Okay, display sample image from the data loader objects. So this step is so simple. It's just about, you know, choosing random image from training set and display it with annotations. You see class 3 is player class. You see class 3, and class 4 is referee. Class 1 is ball, and class 0 must be goalkeeper. Or class 2, I don't know, class 0 will be background probably. Yeah. Yeah, it's same, you see, different image. Okay. So, other step is load a pre-trained faster RCNN model. Yes. I will use ResNet 50 as a backbone. You can use other models. And we need to import Torch Vision as well. Yeah, you see, this is our model. You can see full model like this. Scroll, and you see like there's convolutional layers, ReLU activation function. Like there's so many layers. See? Okay, we can move on. Adjust training parameters. Yes, we have few parameters I can show you. So this params variable is for models trainable parameters. So this means that while training, this weights will be changed. And optimizer, there's like learning rate, momentum, and weight decay. You can change these values depending on your dataset and other metrics. Of course, depending on your model as well. Then here we will train our model. But before that, we have one more step. Yes. First, you need to clone this repository. I already cloned it to here. You see Vision. We will use files from here while training. Let me show you these 5 files. And these are under references detection folder. Let me show you. References detection. Yeah, you see. You need to copy these files to your base folder, but let me do again. Where is that? Wait, I forget what was that. Okay, detection utils. But before that, reference. Okay, sorry. And what was that? Utils transforms. Okay, utils. Well, engine, utils, and transforms. Okay, these 5. So I copied it in the same directory with my main file. Then other step is training. Yeah, it's really simple loop. You can see here. I already trained my model because it took like 1-2 hours, so no need to wait for it. You see, this is a simple loop. Like train one epoch, evaluate, and save the model. You can see models are saved to here under this models directory. Let me show you training process. Yeah, for every epoch there is different informations like learning rates, loss values, and time. For example, this is for epoch 4. You see loss values. And in the end, let me show you. Yeah, it's done. You see. Okay, then training is finished. Other step is load trained model and make prediction on image. Okay, let me copy this. So I will choose model from here. You know, we can choose the last model. This is the IPO 10. You see, like this. And these are classes. Let me check something. Did I forget something? Oh, I didn't explain here, right? Yes. No, I can quickly explain it. Before, like these parameters, you see we are uploading our model here, ResNet 50. This is number of classes. This +1 stands for background class. This is input features, like number of input features for the classifier head. Then this is for, you know, we are loading model, and this is the number of input features, and this is the number of classes. We just calculated to here. You know, +1 is for background. I can show you like input features. You know, this is the integer. Yeah, you see. Okay, then we trained our model, and now we are testing. So number of classes, and we need to choose some image for testing. I'll choose randomly this one. Let me close this, and we can see. Yeah, the actions are done. You see, let me show you. Okay, you can see referee class, player class, goalkeeper, player. For example, it didn't detect the ball, but in other image it can detect or can't detect. We can't know that. So you can test it with, of course, different images, but I don't want to spend time on it right now. You can download images from Google and test it to see how your model performs. So I think if there no okay, I think that's it for this video. Thanks for watching. See you soon.